Hi, Super Scientist. In the section PT3, we're looking at nonmetals and metalloids. So in a previous section, we looked at the metals, which make up most of the periodic table. The metals can be seen in blue in this image. So in this section, we're going to be looking at the nonmetals, which are shown in green, and then the metalloids, which are on this kind of zigzag in this purple color. So we're looking at the characteristics of nonmetals and metalloids. So what is a nonmetal? So in all ways, a nonmetal is the opposite of a metal. So whereas metals were good conductors, nonmetals are going to be poor conductors. So that means that they're not going to be able to conduct heat and electricity very well. A lot of the nonmetals are going to be gas, but a lot of them are also solids. So the ones that are solids are going to be dull and brittle. So brittle means that they would be able to break easily. A lot of the nonmetals are going to be good insulators. So if something is a good insulator, then that means it's going to prevent heat or electricity from being conducted throughout that substance. So for example, a styrofoam cup is an insulator, so it keeps the heat inside of the cup if you have hot chocolate or if you have coffee. And on the outside, the styrofoam cup is going to insulate, and so that prevents your hand from getting burned. The carbon family is the next thing that we're going to look at. So carbon family is going to be group 14. So the carbon family is called the carbon family because of carbon at the top. So this is group 14. You can see in the picture here you have 14 up at the top. So this group has carbon at the very top, so that's the only nonmetal that's here. Then we have two metalloids, silicon and germanium, and then we have tin and lead. Those are two metals. So what we see going on with the next couple groups is that you have a nonmetal at the top, then you have a couple metalloids, and then you have a couple of these post-transition metals, some of these metals that were in mixed groups from our previous section. So elements that are in the carbon family are going to be able to gain, lose, or share 4 electrons in chemical reactions. So just to give you an example of a few of these, tin is something you're probably familiar with. It's a pretty common metal. We refer to these as tin cans a lot of times, so will contain soup or something like that. Silicon is going to be used in computer chips, and we'll come back to that in just a few minutes. And then a few of these other ones, lead is another example that you may be familiar with as well. Nitrogen is next. Nitrogen family is group 15. So within the nitrogen family, we're going to see 2 nonmetals at the top, then 2 metalloids, and then 1 metal at the bottom. So we're adding more nonmetals to these families as we're going across to the right of the periodic table. So in group 15, we have nitrogen and phosphorus. Phosphorus is going to be used in matches. So it's this the substance that's in this red coating on the end of matches to allow for that lighting to occur of the match. And then other elements that we see, antimony is one example you see here. It's a silvery kind of metalloid. And bismuth. Bismuth is my favorite metal. It is so pretty. It's lots of different colors, kind of rainbow colored. And when it forms crystals, it forms these kind of very angular crystals. So it's really interesting. And nitrogen, as we know, makes up the largest percentage of the atmosphere. So nitrogen is really common in our atmosphere. It's about 78%. The oxygen family is next. So the oxygen family is group 16. So on your periodic table, this is 16, group 16. We have oxygen at the top, sulfur, and then selenium. So those are the 3 nonmetals that we have at the top of this particular group. And then we have 2 metalloids below that, tellurium and polonium. So Head and Shoulders shampoo, dandruff shampoo, is going to contain the substance selenium. Sulfur is a kind of yellowy, chalky, brittle material, and if you've ever smelled a hot springs like at Yellowstone, sulfur has a rotten egg kind of smell. So you have, in hot springs, you have a lot of sulfur, methane sulfide, and it has a really rotten egg smell and it stinks. So during chemical reaction, the elements that are in group 16 are going to share 2 electrons with other substances. The halogens are group 17. So the halogens, we do have fluorine at the top, but it's referred to as the halogens specifically, and it's given the special name because of what happens during chemical reactions. So these substances are really highly reactive. They're the most reactive non-metals. So the halogens, halo means salt, gen means producing. So the halogens are salt producing during chemical reactions or salt forming. So they're the most reactive non-metals, and that's because they have this one electron that they're trying to take, because they almost have a complete outer valence shell, and so they have out of 8 valence electrons, generally they're going to have 7, and so they just need one more to make it that full valence shell, and so they always want one more electron. And chlorine is something that you're probably familiar with. Chlorine is added to drinking water, it's added to swimming pools, and chlorine is actually a green gas, but it is added to swimming pools and to water in order to kill microbes. Bromine is something that you probably haven't heard of before. Bromine is the only liquid non-metal. Mercury was the only liquid metal. Bromine is in Sundrop. It's in brominated vegetable oil. So if you look at the back of a Sundrop container, look at the ingredients, you'll see bromine. It's brominated vegetable oil. Iodine is what is in this container. So iodine is used as sort of an antiseptic. It's in a lot of first aid kits. And the noble gases are the last group, group 18. The noble gases do not like to form compounds, and that's because that valence shell that I just mentioned a minute ago, that valence shell for noble gases is complete. It has all the electrons that it can hold in the outermost shell, doesn't want any more electrons, doesn't want to give any electrons away. Helium is something that you're probably familiar with. It's in party balloons, like a birthday party. Neon is what's responsible for a lot of what we call neon signs, and neon signs sometimes will contain other noble gases because they will produce different colors. Hydrogen is an element that's kind of grouped by itself. So it's our first element, it's our smallest element, but it's the most abundant element in the universe. Hydrogen is at the top of group 1, so it's right above the alkali metals, but hydrogen is a non-metal. So again, it's the most abundant element, and here on Earth we see it combined with water a lot of times. So we see the 2 hydrogens combined with 1 oxygen to make H2O. And the metalloids. So the metalloids are elements that are going to have some characteristics of metals and some characteristics of nonmetals. So the metalloids are going to be found on the stair step, this little zigzag area that's in a little bit of darker blue. And the key characteristic of metalloids is that they are semiconductors. And what that means is that under certain conditions, they are able to conduct heat and electricity, but under other conditions, they are insulators. And that is the case with silicon. So this is an example of a silicon chip. And you can see a penny here for reference, just showing you a comparison of the size. So silicon is what is responsible for the electronics that we're so familiar with, cell phones, computers, things like that. So let's recap really quickly. Metals, nonmetals, transition metals, and metalloids. So characteristics of metals, just to compare these really fast. Metals are shiny, malleable, ductile. So they are highly reflective. That's what makes them shiny. They're malleable, so they can be bent or shaped. Ductile, which means they can be pulled into wires. Metals are going to be good conductors, and they can easily lose electrons and can give them away, especially in the case of the alkali metals and the alkaline earth metals. The nonmetals, which we just reviewed today, nonmetals are going to be poor conductors. They are usually reactive with other elements because they are trying to gain electrons. And if they are solid, then they're going to be dull and brittle. But a lot of nonmetals are gases. The transition metals, which are metals, but they make up a large chunk in the center, so that's why we're reviewing that separately. So the transition metals are in groups 3 through 12, and they specifically are going to be less reactive. They have a low specific heat, which means they can heat up pretty quickly. and they have a high melting point. And these are all reasons why we use transition metals for common purposes like cooking. So if you put a batch of cookies on a pan and then put that pan in the oven, it has a high melting point, and so that metal pan is not going to melt. The oven does not get hot enough in order for it to melt. And the metalloids, the last group. So they are solid at room temperature, brittle, hard. They share characteristics with some with metals and some with nonmetals. They are somewhat reactive, just depending on the particular substance, and they are semiconductors, which means under certain conditions they are able to conduct heat or electricity. In other conditions, they are insulators.